Hey you guys, okay, so section 1.4 notes says graphing rays and segments, okay? So the first two graphs, as you can see on the top here, are review questions. We have been reviewing a lot with linear, so I would like for you to take a few minutes and graph those out for me. I will be checking for correction, okay, accuracy on number 1 and 2 when I see you guys next, okay? We have two definitions here, so let's start with that. Let me just make sure okay. First definition is called a segment. A segment is a line segment that has two endpoints. So two endpoints meaning that we have one here and one here, and we can connect them like that, okay? A ray is part of a line that has one endpoint only, and one goes on indefinitely. So it could be this way or it could be that way, okay? Again, make sure you guys pause and complete the two review questions 1 and 2, these ones. Now we have some symbols here that we would like, and please don't forget to pause anytime you want to finish writing down. So we have some symbols here. The first symbol we have is called greater than, and an example is going to be x is greater than -1/2, -1/2. So if we were to draw a number line, here is going to be a -1/2, -1/2, and because we don't have an equal, it's going to be an open circle, okay? And it's going to go to the right. So for this one, open circle. The next symbol is called a less than. So just like greater than, a less than, we're going to go 4, and it's going to be an open circle again. It's x is less than, so it's going to go everything here. And again, this is going to be an open circle. Greater than or equal to, we have +1.7. This is now going to be a closed circle, and it's greater than or equal to, so we're going to go to the right, so close circle. The next one is less than or equal to, so we are going to draw a number line. And -3 is right here. Again, it's a closed circle. The reason we know it's closed because there's an equal sign below here, and it's less than or equal to, so that allows us to go all the numbers on the left side, and we need to know this is a closed circle for us. Equal to, it's just simply a closed circle. There isn't any arrows going left or right because there's only one answer, and that answer is -1.9. And so out of all the numbers on your number line, this only has one answer. Now, how does that relate to our notes today? So our notes today, we have 3 examples, and here are the directions. Graph the given equations over the specified domain, okay? So these are the given domain here. We sometimes call it constraint. Find the domain, range, x-intercept, and y-intercept, and state the interval where the graph is either increasing, decreasing, or constant. So the first one is a point-slope form. Y - 5 equals 1/2 times the quantity of x plus 3. The reason I know it's a point-slope form because it looks similar to this. Right, 1/2, oops, I should write m, times x minus x sub 1. And if it's in the point slope form, just like its name, the point is always going to be x1, comma y1, and the slope will always going to be the variable n. All right, so there are multiple ways to graph. I need to know what the point is, okay, from this equation. And again, it's going to be an x - 1 here, guys. So this is going to say x minus a minus 3 for us to have a positive 3. So this question is going to have a point at negative 3 comma, and then this one is going to say y sub 1, so that's going to be 5. Okay, that's our point. Our slope is going to be 1 over 2. We are only graphing this when x is less than or equal to 1, okay? So that allows me to go, okay, well, x is less than or equal to 1. I'm going to draw this line. I will need to erase it later, okay? I would need to erase this later, but this is where 1 is at, and I want to keep everything over here and erase everything that's not over here. So we will start graphing normally. When you have a point slope form, we will start with the point, which is negative 3 of 5, 2, 4, 5. This is your point, and your slope is 1 over 2. So we're going to go up 1 over 2, up 1 over 2. I can't go any more over here. Remember, I need to graph this line when x is less than or equal to 1. But I can go down 1, left 2, down 1, left 2, down 1, left 2. And don't forget, you need a straight edge, okay? Get a straight edge and And we do need an arrow going to the left because we want all x variables less than or equal to 1. But we can't have anything else on the right side of 1. So now I'm going to go erase all the stuff that I don't need. And that's a what? A segment or array? This is array. Okay. So let's go and look for the domain. Okay. Your domain is all value of x. And x, as you can see, it's already given to us, which is x is less than or equal to 1. Let's fill that in. X is less than or equal to 1. We can also write this as an interval notation. Over here is a negative infinity, and this right here is a 1 unit, so comma 1 unit. This is a closed dot, and the reason I know is a closed dot, guys, is because this has an equal. So that's a bracket right there, okay? So this one can be written as negative infinity to 1 close bracket, or just simply x is less than or equal to 1. Now the range is all values of y, okay? Now y, because this is going downward, that means at some point it's going to hit a negative infinity below. And this right here, according to my scaling, is 2, 4, 6, 7. So this is 7. So we can say that y is less than or equal to 7, or we can write it as an interval notation from negative infinity to 7 and bracket. We will write both here. Y is less than or equal to 7, or negative infinity to 7 and bracket. Next is x-intercept. X-intercept is when y equals to 0. And can you guys see that it's over here because it's going to keep on going? Just because we stop at the green doesn't mean this ray stops, okay? But I can't really see where it crosses, especially if your line isn't straight, or in this case, your ray isn't straight. But I can just simply set y equals to 0. So if y equals to 0, it's going to look like this. X-intercept. Y equals to 0. So 0 minus 5 equals 1/2 here times x plus 3. That's going to allow me to say negative 5 equals 1/2 here times x plus 3. To get rid of your half, we would need to multiply this by 2. And so that will say, this color, I'm going to keep it black. Negative 10 equals x plus 3. Move 3 to both sides, so it's going to be minus 3, okay, from here, minus 3 from here. And now we would have an x equals to negative 13. An x-intercept, we are going to write it as an order pair. So what's happening if we keep on going, it's going to hit this right here, and this is a negative 13 over here. And so write x-intercept as an order pair, guys. Negative 13, comma 0. We can just look at the y-intercept, but again, it's not a nice number that we can pinpoint. So we can, let's try to do some math to see where exactly that location is, okay? Y-intercept is when x equals to 0. X equals to 0. So it's going to say, okay, y minus 5 equals 1/2. 0 plus 3 is 3. Y minus 5 equals 3 times 1/2 is 3/2. Add 5 to both sides. Y equals 3/2, guys, is 1.5. 1.5 plus 5, that's going to give us a 6.5 for y-intercept. And write it as an ordered pair. So it's going to be 0, 6.5. Now this part is new to us. Is this ray increasing, decreasing, or constant? Something that is constant means it's flat, okay? So this ray right here, or this segment, would be a constant. I'm gonna make it 2 arrows as a line. So that's a constant. Now an increase or decrease, I want you to think of this as if we were, okay, to go from left to right on this ray, always left to right, are we hiking up a mountain, or are you sliding down a mountain? So if we go from left to right, and in math, we are always going to go from left to right. If we're going to go from left to right, this is going upward. Another way to think of it is the slope positive? If the slope is positive, then it is an increasing piece, okay? Or sometimes you call it an increasing function. So increasing, and the interval, only use x, okay? The interval for increase and decrease in constant is the same as our domain here. It's the same as our domain. It's going to start somewhere over here. We call it negative infinity. And it's going to keep going up, 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 up until we get to this x location, which we call it comma 1. So it's going to be increasing from a negative infinity all the way to 1.